Hello everyone, in this video we are going to discuss the example for a random variable. Kindly refers to the question, a continuous random variable x has the cumulative distribution function, which means the capital F. So here we have the fx. Question asks us to find the constant or show that a is equals to 4. So number one, what we have to do is to find the a. As we all know, in the cumulative distribution function, we note that we have f1 which is equals to 1. As we can see in the third function. Next, what is f1? By using the second function, kindly substitute the 1, where we will have a minus 3 equals to 1. So, a is equals to 1 plus 3, where we have 4. So, we already shown the situation. Refers to the a, b, and c. We notice that we need the PDF, which is the probability density function. So, what we have to do is to differentiate the situation that we have, which is the capital F. So refers to the situation d dx for the function 0, d dx, as we all know, a is equals to 4. So we will have bracket 4x to the power of 3 over 2 minus 3x squared. Next, differentiate the situation, which is the 1 with respect to x. So kindly differentiate the situation and we will have 0 for this part, same to this part. Next, focus on the second function. Differentiate means that we have to bring forward the 3 over 2. 3 over 2 multiply with the 4, so we will have 12 over 2, which is the 6x. 3 over 2 minus 1, where we will have 1 over 2, minus 6x. So kindly rewrite the function, which is the probability density function. So fx, which is equals to 6x power of 1 over 2 minus 6x. Then we have 0. For the domain, kindly refers to the second function for the capital F, where we will have x is greater equals to 0, less than equals to 1. Another one, we have otherwise. So that is the probability density function. Next is to express the situation in a real number line, where we have 0 and 1 for the function 6x to the power 1 over 2 minus 6x. Otherwise, we have the function 0. Next, kindly refers to the questions. Question asks us to find the mean. So as we all know, the ex, which is equals to integrate for the function x multiply with the function fx with respect to x with the domain negative infinity until infinity. So that is the formula for mean. So now in here we have integrate from 0 until 1. For the function, we have to multiply the x for the fx. So here we will have 6x to the power of 3 over 2 minus 6x squared with respect to x. Kindly integrate the situation. X to the power of 5 over 2. So 6 over 5 over 2 minus 6x to the power of 3 over 3. Simplify the situation. So we will have 12x to the power of 5 over 2 over 5 minus we have 2x cubed with the limit 1, 0. If we substitute 1, we will have the situation 12 over 5 minus the 2. If we substitute 0, and we will obtain 0. So from here, we will have 12 minus 10 over 5. So here we will have 2 over 5. So the expected value will be 2 over 5. Or we can say 0.4. Next is to find the ex squared, where we have the function integrate x squared multiply with the fx with respect to x for the domain negative infinity until infinity. So in here, we have ex squared, which is equals to integrate from 0 until 1, multiply the x squared with the function fx. So we will have the situation 6x to the power of 5 over 2 minus 6x cubed respect to x. So kindly integrate the situation. So here we have x to the power of 7 over 2 over 7 over 2. So here we have 6 minus 6x to the power of 4 over 4. So kindly simplify the situation. So here we will have 12x to the power of 7 over 2 over 7 minus we have 3x to the power of 4 over 2 with the limit 1, 0. So kindly substitute. So here we will have 12 over 7 minus 3 over 2 minus with the 0. If we simplify the situation, and we will have 3 over 14 for the EX square. Continue. Question asks us to find the variant. As we all know, the formula for variant is equals to E bracket x square minus with the expected value square. So here we will have 3 over 14 minus we have 2 over 5 squared, which is 4 over 25. Kindly simplify the situation and we will have 19 over 350 or 0.0543. Next, kindly refers to B, where we have the probabilities that bracket we have x minus 2 over 5 less than 1 over 10. Kindly simplify the situation. Probabilities that x less than 1 over 10 plus 2 over 5 equal the denominator, so we have to multiply with the 2, so we will have 4 over 10. Continue. Probabilities that x less than 5 over 10, which is 1 over 2, which means that 0.5. So here we have the location 0.5. So integrate, start from 0 until 0.5. For the function 6x to the power 1 over 2 minus 6x dx. Kindly integrate the situation 6x to the power 3 over 2 over 3 over 2 minus 6x squared over 2. Limit 0.5, 0. Continue. We have 4x to the power 3 over 2 minus 3x squared. So if we substitute 0.5, we will have the situation 0.6642 minus the 0. So the answer for the situation, probabilities that x less than 1 over 2 will be the situation 0.664. So that is the situation that we are using the PDF. Next, actually if you refer to the question, we can make use of the CDF. So actually we have the CDF. So if you want to find the situation by using the CDF, refers to the second function. The question said x is less than 1 over 2, means that we're going to use the second function. So in here we have f bracket 1 over 2, which means that we can straightforward substitute the situation into the second function for the CDF, where we have 4 bracket, we have square root for x to the power of 3, which means that 0.5 to the power of 3 minus 3x squared, 0.5 bracket, we have squared. So kindly calculate the situation and we will have 0.6642. If you round up the situation into a 3 significant figure, 0.664. So that is the situation for B. Next, continue with the C. Given the situation y is equal to 4x minus 3, question asks us to find the EY, where we have the situation 4EX minus 3 by using the properties, so where we have the situation. Next is to substitute 4 multiplied with 2 over 5 minus with the 3. Then we will have our situation negative 7 over 5 or negative 1.4. Continue. Question asks us to find the variance for y. So variance for y, so meanings that we have VAR bracket 4x minus VAR 3. So remember the properties where we will have 16 VAR x minus we have the 0. Continue. Substitute the variance for x. So if you still remember, we have 16 multiplied with the variance of x, where we have 19 over 350. Simplify the situation. So the variance for the y, which is equals to 152 over 175 or 0.869. So here we are, and thanks for watching.